This week, we're going to be adding, subtracting, multiplying, and dividing positive and negative fractions. So I thought we'd spend a few minutes each day, a couple times this week, reviewing some of the fraction operations you've had before, maybe in the 5th and the 6th grade. So today we're going to review multiplying and dividing fractions. We're going to start with 2/3 times 1/4. Now, if you recall, when you add and subtract fractions, you have to have common denominators, and that's a little more complicated. So that's why I'm starting with multiplying fractions, because when you multiply fractions, you can simply multiply your numerators together and multiply your denominators together, and you'll get your answer. 2 times 1 is 2. 3 times 4 is 12. Then you always need to simplify your answer. You can divide both of those by 2, and your answer will be 1/6. Let's look at another one. 1/3 times 12/17. For this problem, we have it's a little more complicated because 3 times 17 is not going to be something that's easy to calculate. So we're going to do something called cross-canceling. Whenever you're multiplying fractions, you can simplify any numerator with any denominator. So for example, I see 12 and 3 can both be divided by 3. So if I thought about the fraction 12/3, I would divide them both by 3, and I would get 4 and 1. So the trick is to simplify before you multiply, and that makes it a little bit easier. 1 times 4 is 4, and 1 times 17 is 17. We didn't have to do it that way. If we had multiplied from the beginning without simplifying, 1 times 12 would have been 12. And 3 times 17 would have been, I think, 51. And then I could have divided those by 3 and gotten the answer that way. But you can see that this trick helps us to simplify it before we multiply, keeps us from having these big numbers to try to simplify. Okay, let's try another. Let's do a mixed number this time. 1 1/2 times 2/5. When you have mixed numbers, you must change them to improper fractions. That's not the case with adding and subtracting, but that is one issue with multiplying and dividing. 1 1/2, remember you start with the numerator. 2 times 1 is 2, plus 1 is 3. So this is the same as 3/2. And then 2/5 is already a fraction. Once again, you can either multiply straight across, or you can choose to simplify before you multiply. If I multiply straight across, I'll get 6/10, and then I have to simplify it. But instead, I'm going to divide these two by 2, and then I'll just get 3/5. So the answer is 3/5. Now let's look at division. Four-fifths divided by 1/3. You might remember something with division called KCF. It stands for keep, change, flip. And flip is a fancy or an easier way to remember reciprocal. But you take the first fraction, you keep it the same. You change the division to multiplication. And you flip the second fraction, which means you find the reciprocal of the second fraction. And then you treat it like a multiplication problem. 4 times 3 is 12. 5 times 1 is 5. 5 goes into 12 twice with 2 left over. So that's 2 2/5. Okay, let's divide two mixed numbers. Once again, before you can divide, you must change these to improper fractions. Then we have to keep, change, flip. Keep the first fraction. change it to multiplication, flip the second fraction. Got some ugly looking multiplication problems there, or at least one. So I want to see if I can simplify anything diagonally first. I can't on this one, so I'll go ahead. I have to go ahead and multiply 13 times 5. That's going to be 65. 4 times 6 is going to be 24. Think about how many 24s go into 65. There's 24, then there's 48. The next one's going to be 72. It doesn't go in there 3 times, it goes in twice. That would give me 48. That leaves me with 17 left over, I believe. So the answer is 2 and 17 over 24. Now it's your turn to try one. This would be 4/15. This is a multiplication problem, so there's no keep, change, flip. There is no simplifying to do, so you just multiply straight across and leave your answer that way. For this problem, you must change them to improper fractions first. Start with your denominator, multiply and then add. That gives you 5/3 times, that's going to give you 14/5. Luckily, I see that on the diagonal, I have 2 5s. I can divide both of those by 5, and that gives me 1/1. Didn't have to do that step, but it's going to save me a lot of trouble later. 1 times 14 is 14. 3 times 1 is 3. I want to change this to a mixed number. 3 goes into 14 4 times with 2 left over. 4 2/3. This is a division problem, so you'll keep, change, flip. Looking diagonally, there's nothing to simplify, so now I'm going to multiply straight across. 20 over 7. 7 goes into 20 2 times with 6 left over. Last problem. First, rewrite these as improper fractions. Next, you'll keep, change, flip. Before multiplying, I check to see if there's anything that can be simplified. I don't see anything. Yes, 9 and 3 have common factors, but they're not on the diagonal. 9 times 3 is 27. 2 times 7 is 14. 14 2 times would give you 28. So that means 14 only goes into 27 once with 13 left over.